My name is Shayan Hosseinpouli. I am from the Mondays lab section. My partner Kijung and I did the garage door project, and we would like to present it to you. First, I would like to talk about the project goals and the challenges that we faced in the beginning. The first one would be the detection of the car for our garage door and an appropriate response upon detection of the car, and a practical working logic for the process of working of a garage door. So the detection of the car was done at two states. The first, the car being outside the garage door, needing us to open the door and getting inside. The detection was done by two photoconductors. The one at the outside detects the car being outside the garage and opens up the door respectively. And the second state would be the car being inside the garage door. The detection is done by our second photoconductor, locating the car inside the garage, and the response to that would be the closure of the garage door. And we also needed a working logic for this whole process that was done by two manual switches, which I'm gonna explain further to you. So I'm going to talk about the basic theories that we used to make this project work. The first one is that having the photoconductors, they have a high resistance when they're covered and darkened, or the resistance drops upon being illuminated. And we also made use of the voltage divider law, and we used transistors that they're kind of electronically used switches, and also we used manual switches. So our car being placed outside the garage and covering the first photoconductor, it will result in high resistance of that photoconductor, and according to the voltage divider law, the voltage would be low for that photoconductor, resulting in a low negative voltage of the base of our second transistor. The negative voltage for a second transistor will result in turning on that transistor and opening the garage door in the forward direction. So that will open up the garage door, and the door will keep on opening until it will click our first manual switch, and that switch will stop opening of the door, which the door would be at its peak and stopped giving our car the time to enter the garage. So after our car entered the garage, it will cover the second photoconductor, and being detected by that means that the car is located inside the garage, and that would result in needing to close the garage door. So the closure is done after the car covers the second photoconductor, resulting in a high resistance for the second photoconductor, and that will lead to turning on the first transistor with a high positive voltage, resulting in the reverse direction rotation of the garage door, which will close the garage door. And the garage door will keep on closing until our second manual switch will click, indicating that the door has reached its place to close, and it will stop closing. So this is the picture from this point from the garage door. I'm gonna show you the components that I just talked about. So this is our first photoconductor, and the car will enter in this direction from right to left. And when it covers this photoconductor, the resistance increases for that, and our circuit is down below. So the garage door will open up in this direction, in a clockwise direction. That's our forward direction, being resulted from the negative base voltage of the second transistor. It will keep opening until it hits, this is our first manual switch, which indicates that the door has reached its peak for the opening, and it will stop the opening, giving the car enough time to enter the garage from right to left. And when the car has entered, it will cover the second photoconductor being here, resulting in a high resistance of that, and leading to high positive voltage going to our first transistor, resulting in the reverse rotation of the garage door, which would be counterclockwise, and closing the garage door in this direction counterclockwise, and it will keep on closing until it will click this second manual switch right there, indicating that the door has reached its place to close, and it will stop closing. Pause.
Hi, my name is Kijung, Shayan's partner, and then I'll be talking about the transistors that we use for the bidirectional motor circuit. So for our circuit, we used NPN and then PNP transistors, and then here is NPN transistor, and then here is PNP transistor. So when the car tries to go to the garage by covering the first photoconductor, so the base voltage of both transistors become low, and then become negative and low, which means that so for the PNP transistor, the base voltage will be negative, which means that this PN junction here is forward biased, which means that this circuit is in active mode. And then when the PNP transistor is in active mode, it would cause the motor to rotate forward, which would open the door. And then when the car is inside the garage and covers the second photoconductor, the base voltage will be high, positive high, and then it will make this base NP junction forward biased, and it will turn on the circuit. It would cause, and then since it's in active mode, the circuit or the transistor would cause the motor to rotate in a reverse direction, and then it will close the garage door. And then for our circuit, we use 2 switches before each transistors, so that when the door is either completely open or completely closed, the motor stops rotating. So when the car tries to go into the garage by covering this photodiode L1, it would induce negative voltage on the base, negative low voltage, and it would cause this PNP transistor to turn on, and then it would cause forward direction, and it would open the garage door. And then when the door is completely open, the door would click on the switch, which is S2 right here, and then the door would stop opening. And when the door stops opening, the car goes into the garage, and then when the car is inside the garage completely, it would cover this second photodiode and then not covering this. It would cover this second photoconductor, and then it would induce plus high voltage across the base of each transistor, and then it would cause, and then the positive voltage will turn on this Q1 right here, first NPN transistor, and then the motor will rotate in a reverse direction, causing the door to close. And then when the door is closed completely, the door will click on the first switch, which is the first switch right here. And then when the first switch is clicked, the circuit will be open, and then the Q1 will be turned off. So for the testing, so we shortened the circuit to test the voltage across this node right here. So first we removed L1 and then put VCC across this node right here to see if the motor actually rotates forward, and then we removed this photoconductor right here, and then put VCC onto this node to see if the motor rotated in a reverse direction. And then to measure the voltages, we use the DMM. So this is our plan that we had before, considering the switch design of the circuit. So what happens is these R4 and R5 would be photoconductors that detects whether the door is completely closed or completely open, and then when this photoconductor is covered, it would turn on the second transistor, causing the door to open, which is the same logic as our switch circuit. And then when R2 is covered, it would close the second switch and the negative voltage will be induced, or positive voltage will be induced across the bases of each transistors, and then activating Q1, and then the motor would rotate in a backward direction. And then we used the NPN bipolar transistor to act as a switch, so that the MIDAC would control the gate or the motor, depending on whether the door is completely open or whether the door is completely closed. So these R4 and R5 photoconductors will be connected to MIDAC as sensors that detects whether the door is completely open or completely closed. And then depending on that, this Q3, this transistor right here, would control the door by stopping the motor when the door is completely open, and then stopping the motor when the door is completely closed. So we made a garage door using bidirectional motor circuit and the lab manual, and then we added 2 switches to the circuit from here and here. When either of these switches are activated, one of the transistors is disconnected, and then the motor stops. And as you can see, there are 2 photoconductors in this setup. And then when the car covers the photoconductor, the voltage across this photoconductor turns into plus VCC, and the door opens until this switch is activated, right here. And then when the door is opened completely, like this, the car goes into the garage and covers the other photoconductor right here. And then and then when this photoconductor is covered, this photoconductor causes the door to close, and then turns into negative VCC, and then the door closes until this switch right here is activated, right here.
So we're gonna show you how the car will enter the garage. As you can see, the switch right here is in a closed mode, having the garage door closed. So this is our car proceeding to the first photoconductor. It will open until the switch right here closes up, leaving the door open for having space to have the car enter the garage. So now the car is entering, and as you saw, the door closed pretty fast, and it kept closing until the door clicked our other switch right there, disconnecting the circuit and having the rotation stop.